Stand here with me for a second. It's early, the light's still gray and flat, and the crowds haven't come yet, so for once the place is empty and quiet. You're standing down on the arena floor of the Colosseum in Rome, and you do the thing everybody does when they get down here. You look up, and what's above you doesn't make sense. It's a wall of stone 4 stories high, curving away from you on both sides until it comes back around and meets itself. A great stone oval, open to the sky, with row upon row of arches stacked on arches stacked on arches, climbing up and up into the morning. There is no hill under it. There's no mountain it's carved into. It is just standing there in the open in the middle of a city, holding itself up on nothing but its own arithmetic. And I want you to feel how wrong that is. Because stone is heavy, and stone is brittle, and a tall wall of it, standing free in the air with the wind pushing on it and nothing behind it, is exactly the sort of thing that wants to fall down. Every instinct a builder has says, that shouldn't stand. Not for a storm, certainly not for 2,000 years, but it has stood for nearly 2,000 years, through earthquakes, through fires, through people quarrying great chunks of it away for other buildings, beaten up, half-robbed, patched, and it is still here, still holding that shape, still standing in the open where nothing that big and that heavy has any right to. So let's work it out. Not with mystery, with stone and arches and load. Because the answer to why this thing is still standing is also the answer to a question nobody thinks to ask about the Colosseum. Everyone asks what happened here. Almost nobody asks the better question, the builder's question. How do you get 50,000 people in and out of a stone box in the middle of a city, and how do you make the box hold them up? Because that, it turns out, is what this building really is. It isn't a monument, it's a machine. My name's Dan, and I'm a structural engineer, which means the thing you probably came here to think about, the games, the gladiators, the terrible things that happened on this floor, is not, I'm sorry to say, the thing I think about when I stand here. I've tried. My head won't do it. My head is looking up at those stacked arches and doing what it does on every job I've ever worked, which is tracing the load. Let me explain what I mean because it's the whole video. When I look at any building, I don't really see walls and floors. I see weight, and I see where the weight has to go. Every kilogram of stone, every person sitting in every seat, every gust of wind, all of it is a load. And all of it, in the end, has to travel down through the structure and into the ground, or the building comes down. My entire job, stripped right back, is making sure every load in a building has a clean, honest path to the earth. We call it the load path. Find me a building that's still standing after 2,000 years, and I'll show you a set of load paths that somebody got exactly right. And the other half of my job, the half nobody outside the trade ever thinks about, is people. Moving them. A building isn't just holding up stone. It's holding up crowds, and crowds have to get in, and far more importantly, crowds have to get out fast, in the dark, in a panic, without crushing each other. I have sat in more meetings than I can count arguing about exit widths and stair counts, and how many seconds it takes to empty a room. It is the least glamorous thing in engineering, and it is the thing that quietly saves the most lives. So I look up at the Colosseum and I don't see a ruin. I see two problems I spend my whole working life on: hold the weight, move the crowd, and I see them solved both at once, at enormous scale, by people with no steel, no calculators, and no computers. Solved so well the thing is still standing. So no, I'm not going to tell you a single gladiator story. I'm going to show you the machine. First, the plain facts, because I like to build on solid ground. This building has a proper name, and it isn't the Colosseum that came later. Its real name is the Flavian Amphitheatre because it was built by the Flavian emperors. It was begun under the Emperor Vespasian, and it was opened by his son Titus in the year 80 Anno Domini, ad 80, with 100 days of games. And here's a detail that's easy to skate past, but that I think matters. It was paid for in large part with the spoils of war, the treasure and the labor that came out of the Jewish war, the sack of Jerusalem about a decade earlier. This astonishing feat of engineering was, in its bones, a victory monument funded by conquest. I'm not going to pretend otherwise. The engineering is a marvel and the money behind it was blood and plunder. Both things are true. Now the size. An oval, roughly 190 meters by 155. Call it 600 feet by 500. The outer wall stood about 50 meters high, 4 stories, which is a 15-story building's worth of open stone facade. And inside, the number everybody quotes, room for around 50,000 spectators. And right there on that number, I have to keep my first promise to you because accuracy is sacred to me and I flag the soft spots out loud. That 50,000 is an estimate. It's a good, careful estimate, but nobody has the original ticketing spreadsheet. Some scholars reckon it held rather more, some rather less, depending on how tightly you pack a Roman backside onto a stone bench and how you count the standing room at the top. So when I say 50,000, here roughly 50,000 give or take, and reasonable people argue about it. The point that survives the argument is this. It's a crowd the size of a modern football stadium, and they built it to fill and empty like one, too. Now here's the thing that, as an engineer, actually stops me. It's not the size. It's that it's freestanding. Let me tell you how everybody before the Romans did this. If you were a Greek and you wanted to seat a big crowd to watch a show, you found a hillside, a nice natural slope, and you carved your rows of seats into it going up the hill, so the hill itself held the audience up. Smart, cheap, and it works, but it means your theater can only ever be where a convenient hill already is. The ground does the engineering, you're just decorating it. The Romans didn't do that. They plonked this thing down on a flat valley floor in the dead center of Rome, where there was no hill, and they built the hill, out of stone and arches. They manufactured an artificial mountain of seating, 50 meters tall, standing in the open air, and then they held 50,000 people up on it. Think about what that means for the load path. On a Greek hillside, every spectator's weight goes straight down a few feet into solid earth. Easy. In the Colosseum, a man sitting in the top row is 50 meters up in the air, and his weight, and the weight of the stone bench under him, and the stone holding that bench, and the tens of thousands of people around him, all of that has to be carried down through the building and delivered safely to the ground. There's no hill to help. The building is the hill. Every ounce of that colossal load has to find its own way down through a man-made structure, and if the Romans got the path wrong anywhere, it doesn't sag a little. It comes down. So the real question is, what carries it? And the answer is the single greatest idea in all of Roman engineering: the arch. But before the arches, before anything, you have to talk about the part nobody ever photographs: the foundation. Because the cleverest structure in the world is useless if it's standing on mush, and here the Romans were building on a genuinely awful spot. This was a valley floor between the hills of Rome. It had held a lake, an ornamental lake in an emperor's palace grounds, before the Flavians drained it and, rather pointedly, gave the land back to the people as a place of public games. Soft, wet, made-up ground. The worst thing you can build heavy on. So the first thing the Romans did before a single arch went up was dig down and lay a foundation on a scale that is honestly hard to picture. A vast ring of concrete, Roman concrete, which we'll come back to because it's a miracle in itself, poured many meters deep, following the oval of the building all the way round. Not a slab under the whole thing, a donut, a colossal concrete donut, deep and wide, sitting under the ring of the structure where all the weight was going to come down, spreading that weight out over the drained ground so the building wouldn't sink or tilt. As a foundation engineer, this is the part I actually find most impressive, and it's the part on every job that eats your budget and none of the glory. You can't see it. You'll never see it. It's buried. And it's the reason everything above it is still standing straight. The Romans understood, without any of my soil mechanics, that a heavy building on soft ground needs a huge, deep, continuous foot to stand on, or it will lean and crack like a tower I could name in Pisa that skipped this lesson. They did not skip it. They overbuilt the foundation on purpose and bought themselves 2,000 years. Now, on top of that ring, the arches. And I need you to really understand the arch because it is the hero of this whole building, and most people walk right past it. Here's the problem the arch solves. Stone is fantastic at being squashed. You can pile it miles high and it's happy, it just gets more compressed. But stone is terrible at being bent, at being stretched. Lay a long flat slab of stone across a gap like a bridge and put weight in the middle, and the bottom face has to stretch. And stone hates stretching. It cracks and snaps. So if you build only with flat stone beams across the top of posts, the way the Greeks mostly did, you're limited to short little gaps and forests of thick columns, because stone won't span far without breaking. The arch is the way out. Instead of one straight beam that has to bend, you build your opening as a curve out of wedge-shaped stones. And here's the beautiful part. When you load an arch from above, every stone in it gets pushed, squashed against its neighbors. Nothing is being stretched. Nothing is being bent. The weight from the top runs down through the curve, stone pressing on stone, and comes out at the bottom as a push, sideways and down, into the solid piers on either side. You have turned a load that stone can't handle bending into a load stone loves pure squashing. That's the trick. That's the whole trick. And once you have the arch, you can do things flat stone could never dream of. You can span wide openings. You can stack the arches in tiers, one row on top of another, each row's piers landing on the arches below and passing the load down. And you can sweep an arch around in a line to make a tunnel. We call that a barrel vault, or cross two of them to roof a square bay. The Colosseum is, structurally, almost nothing but this one idea repeated with total confidence. Ring after ring of arched piers, tier on tier, with vaulted passages threading between them. The whole building a three-dimensional lattice of arches carrying that 50-metre-high crowd down to the foundation. The seating you sat on wasn't resting on a hillside. It was resting on the tops of vaults, which rested on arches, which rested on piers, which rested on that concrete donut, which rested on the drained earth. That's the load path. Follow any spectator's weight and it runs, cleanly, all the way down that chain to the ground. Get one link wrong and it falls. They got every link right. And here's where they go from clever to genuinely brilliant. And it's a thing I wish more modern builders understood in their bones. They match the material to the load. Think about it. Down at the bottom of the building, the piers are carrying everything, the entire weight of every tier above. That's the most heavily loaded stone in the whole structure. So what did they build the lower skeleton out of? Travertine. A hard, dense, strong limestone quarried out at Tivoli and hauled to the site. And the estimates for how much they moved are eye-watering. hundreds of thousands of tons of the stuff on a purpose-built road over years. They put their strongest, heaviest, most expensive material exactly where the load was highest. The big travertine piers are the bones of the building. But then, as you go up, the load gets less. The higher stones only have to carry what's above them, and there's less and less above them the higher you climb. So why on earth would you keep hauling heavy, expensive travertine all the way to the top, where you don't need its strength, and where every extra ton up high is just more weight pressing down on everything below? You wouldn't. And they didn't. Higher up they switched to lighter stuff, tufa, a softer, lighter volcanic stone, and above that, brick-faced concrete, which is lighter still and can be shaped into those vaults far more easily than cut stone ever could. Heavy, strong material low, where the loads are brutal. Light material high, where they are gentle. It sounds obvious when I say it, but it is exactly the kind of discipline that gets thrown out of a modern job the moment someone's in a hurry. My foreman Mike would have used whatever was on the back of the nearest lorry and called it near enough. The Romans tuned the whole building layer by layer to put the right stone in the right place, saving weight, saving cost, and easing the load on everything underneath, all with one decision. That's not decoration. That's an engineer thinking. So that's how it holds the weight up. Now for the part I actually find the most modern, the part that makes me think these people would have walked onto one of my projects and run it better than I do. How it moves the crowd. Remember, 50,000 people, and a Roman crowd at the games was not a calm crowd. You need to get all of them in before the show, seated in the right place by rank, because Roman society was rigidly sorted, and where you sat said exactly who you were. Senators down at the front on the good marble, the poorest and the women right up at the top. And then at the end, or if something went wrong, you need to get all 50,000 of them out again. Safely, without a crush. That is a monstrous logistics problem, and it's the same one I lose sleep over on any stadium or arena today. The Roman solution was, frankly, better than a lot of what I've seen built in my own lifetime. Around the base of the building ran a ring of about 80 arched entrances. 80. Not 2 grand doors, 80 ordinary ones, spread evenly all the way round so the crowd never had to funnel through a few pinch points. And they were numbered. Your ticket, a token, often a bit of pottery or bone with marks on it, didn't just tell you your seat. It told you your entrance, your staircase, your level, your section. You came in through your own numbered arch, went up your own stairway, and came out through an opening right by your seat. And those openings have a name that tells you everything about how the Romans thought about this. They called the passages the vomitoria. From the Latin to spew to disgorge, because the building was designed to vomit its crowd out. The name is about flow. The whole interior is threaded with these vaulted passages and stairways, arranged so that the mass of people is constantly being split into smaller and smaller streams heading for their own section. And then, on the way out, all those little streams pour down and combine and gush out of the 80 arches around the base. The result, and ancient writers boasted about this, so treat the exact figure as a boast rather than a stopwatch, but the principle is dead sound. The result was that this building could fill and empty astonishingly fast. Some say the whole crowd could clear in minutes. Whether it was quite that fast or not, the design logic is exactly, precisely what we still do today. Many exits, evenly spread. Split the crowd early. Give every person a preassigned route so nobody's crossing anybody else's path. Never let the whole mass pile into one door. I have drawn that exact diagram, the branching flow of an emergency exit plan, for modern buildings. And then I've come here and found the Romans built it into stone 2,000 years ago, and did it better, at bigger scale, than half the venues you've queued to get out of. This is the machine. The building is a machine for moving a crowd, and the seating is almost the byproduct. And now the detail that, when I first understood how it worked, made me actually laugh out loud with delight. Because it's the moment the building stops being architecture and becomes engineering theater. The awning, the Velarium. Rome is hot. Sitting in a stone bowl in the Italian summer sun for a full day of games would cook you. So the Romans put a roof over the crowd. Not a solid roof. You can't roof a span that huge in stone, not even they could, but a vast retractable fabric awning, panels of canvas that could be pulled out over the seating to throw the whole audience into shade, and pulled back when you didn't want it. A convertible roof. On a building the size of a stadium. 2,000 years ago. Here's how, as best we understand it, and it's gorgeous. Around the very top rim of the outer wall, there was a ring of stone corbels and sockets. You can still see them. That held a forest of tall wooden masts standing straight up above the top of the building. From the tops of those masts, ropes ran inward and downward to the fabric, and outward and down to great anchor points on the ground outside the building. And by hauling on those ropes, you could run the canvas out along the rigging toward the center or reel it back to the edges. It was essentially a giant horizontal sail. And who do you think worked it? Not soldiers, not slaves off the street. Sailors. A detachment of men from the imperial fleet, based down at Misenum on the Bay of Naples, actual Navy sailors, brought up to Rome for the job. And the instant I heard that, the whole thing clicked, because of course it was sailors. Who else on earth in the ancient world knew how to handle acres of canvas and miles of rope on a forest of masts, reading the wind, hauling in a team, not letting the whole rig take off in a gust? The people who spent their lives doing exactly that on the decks of ships. The Romans looked at a rigging problem and hired riggers. That's not just clever engineering, that's clever management, and it's the kind of thing that tells you these people thought about the whole system, not just the stone. Which brings us underground. Because there's a whole other building you can't see, beneath the one you can, and it's the strangest, most machine-like part of all, the hypogeum, under the arena floor. And I have to flag this straight away because chronology matters and accuracy is sacred. This part was added a little after the opening. It wasn't there on the very first day. Under the arena floor, the Romans dug a 2-level warren of tunnels, corridors, and cells. This was the backstage, the machine room. Down here they kept the animals, the scenery, the equipment, the men waiting to go up. And running through it, more than a dozen, some say 20 or more, vertical shafts fitted with lifts, hoists. And these weren't dumbwaiters. These were serious pieces of kit. A platform in a shaft, a rope over a system of pulleys and a great turning drum, or capstan, that a team of men pushed round, and a counterweight to balance the load so muscle alone could raise a heavy cage or a loaded scenery platform from the dark up through a trapdoor and into the blazing arena in front of 50,000 people, seemingly out of nowhere. A whole animal or a chunk of painted forest appearing through the floor as if by magic. The magic was counterweights, pulleys, and coordinated muscle. It was a theatrical machine, a lift system, a special effects department in stone and timber and rope, running in the dark beneath everyone's feet. And I want to be honest about something here, because it's the kind of thing that gets exaggerated, and I won't do that to you. You'll often hear that the arena was flooded for mock naval battles, naumatia, staged sea fights on real water inside the Colosseum. And it's a genuinely debated point, So here's the honest version. Some early Roman accounts do describe water spectacles in the very earliest days, before the hypogeum was dug. But once you fill that space underneath with a two-level warren of tunnels and lift shafts, flooding the floor becomes wildly impractical. You'd be drowning your own machine room. So scholars genuinely disagree. Maybe there were water shows early on, in a way we don't fully understand, before the basement went in. But the idea of the Colosseum as a permanent, reliable water tank for its whole life almost certainly isn't right. Where the evidence is muddy, I'll leave it muddy rather than tidy it up into a story. What's not in doubt is the hypogeum itself, a working underground machine and one of the most sophisticated the ancient world ever built. So step back with me and look at the whole thing again, now that you can read it. The foundation, a deep concrete ring spreading the load over drained ground. The travertine bones, the strong stone put exactly where the load is worst. The arches and vaults, turning bending, which stone hates into squashing, which stone loves, and carrying a 50-metre-high crowd cleanly down to the earth. The materials tuned tier by tier, heavy low and light high. The 80 numbered entrances and the vomitoria, a crowd flow machine that splits 50,000 people into streams and pours them in and out in minutes. The Velarium, a convertible fabric roof worked by Navy riggers. And the hypogeum, a hidden basement full of lifts and counterweights. That is not a building in the way we usually mean it. It's a system. Every part of it is solving a physical problem. Hold the weight, move the crowd, shade the sun, work the show. And every part is solved with a confidence and an economy that I, doing this for a living with all my modern tools, look at and feel a bit humbled by. Try getting that past a modern safety inspector. An open-air stone bowl for 50,000, a rigged canvas roof on wooden masts, and a basement of rope-end counterweight lifts hauling animals up through trapdoors. And yet the crowd flow logic underneath it is so sound that we still, genuinely, design exits the same way today. And it brings me right back to where we started, to you standing on the arena floor at dawn looking up at a wall of stone that shouldn't be able to stand. Now you know why it can. It's not standing in spite of physics. It's standing because a group of people understood physics, the physics of load, of the arch, of the ground, well enough to give every ounce of weight in that colossal building a clean, honest path down to the earth, and then built that path out of the right material in the right place. That's it. That's the secret. There's no lost magic here. There's something much better than magic. There's understanding. And I'll tell you what it does to me professionally, because it's not entirely comfortable. Half the modern buildings I've worked on are designed to last 50 years. 60, if they are lucky, before something fails or someone knocks them down. We build faster than the Romans ever could, with materials they'd have wept for. And we build things that don't last a single Roman lifetime. This thing has outlived the empire that made it, every language they spoke, and every single person who ever doubted it. And it did it because the people who built it weren't in a hurry to be finished. They were trying to be right. My intern Priya asked me, standing about where you are now, the question that always cuts straight to it. She said, "So are we actually worse at this than they were?" And the honest answer is no, we're not worse. We know far more than they did. We're just, too often, not trying to build something that outlives us. They were. And here's where I turn it round on you, because I didn't stand you on this floor just to admire some old arches. There's a lesson sitting in that load path, and it isn't really about stone. It's about how a thing lasts. Everything in your life that's still standing years from now, the work you did, the things you built, the people you held up, all of it is carrying a load, and all of it is only going to stay up if that load has somewhere honest to go. The Colosseum lasted because nothing in it was faking. Every arch was really carrying its share. Every pier really went all the way down to solid ground. There was no hidden weakness dressed up to look strong, no load quietly dumped somewhere it didn't belong, hoping no one would notice before the handover. When you build like that, when the strength is real all the way down, when the heavy work is done in the parts nobody will ever see, like that buried foundation, you get something that stands for 2,000 years. And when you don't, when you fake the strength and hide the weakness and rush to be finished, you get something that looks fine at the opening and comes down the first time the ground really shakes. I think about that more than I probably should, and not just about buildings. The most important load-bearing work in anyone's life is the part nobody sees, the foundation poured deep in the dark, that everything visible is quietly standing on. Get that right, overbuild it, do the unglamorous thing properly, and you can put something tall and open and daring up on top of it and trust it to hold. Skip it, and it doesn't matter how beautiful the arches are. So the next time you see a picture of the Colosseum, I hope you don't just see a ruin where terrible and extraordinary things happened. I hope you see the machine, the load finding its way down, the crowd finding its way out, the right stone in the right place, a group of human beings who understood their materials and their people well enough to build a thing that has outlasted almost everything else humans have ever made, not by magic and not by luck, but by getting the load path right, all the way down to ground they'd bothered to prepare. So that's my question for you, and I do read the comments genuinely. Here it is. What's something in your life that only lasted because of the invisible foundation under it? The boring, unglamorous work you did where nobody was watching, that everything good ended up standing on. Or the other way round. What looked great at the opening and came straight down the first time it was really tested, because the strength wasn't real all the way down? I genuinely want to hear it. Put it down below. I'm going to go and try, one more time, to explain to Mike why it'll probably hold is not the same sentence as the load has somewhere to go, and to convince Priya that admiring the Romans is allowed, as long as we go home and build ours to last longer than 50 years for once. And if you like standing in an empty arena at dawn and actually working out how the impossible thing holds itself up, no mysteries, no nonsense, just stone and arches and a people who understood their loads, then subscribe and come back, because next time I've got another one that's still standing, still holding, still quietly showing us up. My name's Dan. Mind the load. And the next time somebody calls the Colosseum a ruin, stand them on that floor, tell them to look up, and let the arches explain why it's still here.